Okay, part 284C3M1b7C8E13c9c6d3p34j. Line 22f1fa19c3m1b7c8E13c9c6d3p34j. Light cone string field theory 5G Wow Seti. Here's our alien radio signal, and this video is about the keyword research string theories for UFO WOW data. The keyword Witten's cubic open string field theory is going to be in the next video. So this is just all keyword research for the next several videos, okay? These were words I didn't understand what they are, so this is basically teaching me what they mean. So January 26, 2013, today's February the 11th. The keyword BET Brunauer-Emmett-Teller to keyword Arrhenius law from a previous video, line 22f1fa19c3m1b7c8e13c9c6d3p33. Brunauer-Emmett-Teller Raney nickel metals 5G Wow Seti. February 3rd, the keywords Newton's law to classical wave, to wave velocity, to pulse wave velocity, to velocity, to forward traveling wave are from a previous video, line 22f1fa19c3m1b7c8e13c9c6d3p34j. Front velocity aerodynamic flows 5G Wow Seti. Okay, so the keyword light cone string field theory. Quotes and diagrams are from Wiki. The light cone string field theories were introduced by Stanley Melderstrom and developed by Mandelstam, Michael Green, John Schwartz, and Lars Brink. An explicit description of the second quantization of the light cone string was given by Miko Kaku and Keiji Kakawana. Sorry if I said your names wrong. Light cone string field theories were the first string field theories to be constructed and are based on the simplicity of string scattering and light cone gauge. For example, in the bosonic closed string case, the worldsheet scattering diagrams naturally take a Feynman diagram-like form being built from two ingredients, a propagator, which is this thing here, and there's some sort of formulas there, P and X, and two vertices for splitting and joining strings, which can be used to glue three propagators together. So there it is there. The three vertices and propagators produce a single cover of the moduli space of n. Point closed string scattering amplitudes, so no higher order vertices are required. Similar vertices exist for the open string. When one considers light cone quantized superstrings, the discussion is more subtle as divergences can arise when the light cone vertices collide. To produce a consistent theory, it is necessary to introduce higher order vertices called contact terms to cancel the divergences. Light cone string field theories have the disadvantage that they break manifest Lorentz invariants. However, in backgrounds with light-killing vectors, they can considerably simplify the quantization of the string action. Moreover, until the advent of Berkotov's string, it was the only known method for quantizing strings in the presence of Riemann fields. Research. Light cone string field theory played an important role in understanding strings in PP wave backgrounds. Now, I've seen that one before, PP wave. Okay. Free covariant strings field theory, an important step in the construction of covariant string field theories preserving manifest Lorentz invariants, was the construction of a covariant kinetic term. This kinetic term can be considered a string field theory in its own right, the string field theory of free strings. Since the work of Warren Siegel, it has been standard to first BRST quantize the free string theory and then second quantize, so that the classical fields of the string field theory includes ghosts as well as matter fields. For example, in the case of the bosonic open string theory in 26-dimensional flat spacetime, a general element of the Fock space of the BRST quantized string takes the form in radial quantization in the upper half plane. I don't know if you can see this. It's really hard. It's kind of thin lettering. But there's a formula or something there, where 0 is the string vacuum and the dots represent more massive fields. In the language of worldsheet string theory, T, A, and X represent the amplitudes for the string to be found in the various basis states. After second quantization, they are interpreted instead as classical fields representing the tachyon T, gauge field A, U, and then a ghost field X. In the worldsheet string theory, the unphysical elements of Fock space are removed by imposing the condition of that, as well as the equivalent relations of that. After second quantization, the equivalence relation is interpreted as a gauge invariance, whereas the condition that this little symbol is physical is interpreted as an equation of motion. Because the physical fields live at ghost number 1, it is also assumed that the string field, in this little symbol here, is a ghost number 1 element of the Fock space. In the case of the open bosonic string, a gauge unfixed action with the appropriate symmetries and equations of motion was originally obtained by Andre Nouveau, Hermann Nicolai, and Peter C. West. It is given by, there's the equation, where that little symbol is the BPZ dual of that and 16. For the bosonic closed string, construction of BRST-invariant kinetic term requires additionally that one impose those equations, and the kinetic term is then, hold on, make it a little bigger, free closed, blah blah blah. There's the equations. I don't know what that stuff means. Additional considerations are required for superstrings to deal with the superghost zero modes. Keyword Witten's cubic open string field theory is in the next video. Thanks for watching.